Welcome. So today we're going to talk about summation formations. I'm sorry, summation formulas. It's easy to get your words tied there. We'll talk about the notation, what it means, some formulas, and then do examples. So, the notation is the sum of f of I as I ranges from A to B. We're just taking whatever this is, plugging A in, plugging A plus 1 in, plugging A plus 2 in, and so on until we get to B. So for example, from I equals 3 to 5 of I squared minus 1 is plug 3 in, plug 4 in, plug 5 in, and add those up. That's how you do it. That's what it means. So, why would you do that? Because maybe you have it's a compact way of saying something. 3 to 5, this is kind of a waste of a notation, but if it were 30 to 500, you don't want to write out the 30th one, the 31st one, the 32nd one, the 33rd one, all the way up to the 500th one. That's just too much to write. This is an easier way to write it. Now, people have worked on these. They've come up with some formulas. There are ways to simplify. For example, if I put a number in front of everything, it stands to reason. 2x plus 2y plus 2z, what can you do? You can pull the 2 out of the summation. Likewise, in the formal summation notation, anytime there's a number in front of everything, you can just pull that number out. If I'm adding two things, and I'm adding them for here, then I'm adding them for here, then I'm adding for here, and so on, I can pull all of the first ones out, all of the second ones out, and instead add all the firsts together, plus, well, or minus, depending on which way, all the second ones. If you should notice, these are very similar. We've seen these kind of properties before. These properties make an operation what's called linear, because you multiply by a number, the number can be pulled out. You add two things, you can separate them. Derivatives do this too. So do antiderivatives, actually. But the next parts are unique to summations. If I add 1 up n times, 1 plus 1 plus 1 plus 1 plus 1, what's that? It's 5. You take from 1 to n, add them up, you get n. There's nothing magical about that, that's just common sense. However, if I take 1 plus 2 plus 3 plus 4 plus 5, if you do that, that's 15. How do you get to there? Well, you take the number, so in this case 5, and one more, so 6. 5 times 6 is 30, divide by 2. This formula works for any n. Going from 1 to n, it gives you n times n plus 1 over 2. There are ones for squares inside here. There it is, n times n plus 1 times n, 2n plus 1, all over 6. And there's one for cubes. N squared times n plus 1 quantity squared, all over 4. These formulas, where do they come from? It's really interesting, and if you want to, in Math 300, we talk about how to prove these by something called induction. For now, they're just magic. Let's use them. Let's take 3i squared, it's going from 1 to 10. Well, the thing that's different about this one than what we had before is there's a 3 there. But we know what we can do with a 3. You can always just pull the 3 out. Well, that, according to the formula, is 10 times 11 times 21 all over 6. That's hard to do in my head. Just a couple of numbers multiplied together. So this is the sort of thing that calculators were invented for. 3 times 10 times 11 times 21 divided by 6. Notice we're dividing, but it doesn't matter. Because that 6 is going to be factored out of this. It's never going to be a fraction if those are whole numbers. What about the next one? Actually, there's 2 more. I'll let you think about these 2. Okay, let's see. I've got a minus sign, so I can do this from I equals 1 to 10 of I, minus doing the same thing. I'm going to pull the 2 out. So I'm doing this minus 2 times doing that one. And the first one, according to our formula, is 10 times 11 over 2 minus, and the next one is, adding 1 up 10 times is just 10. So that's 110 over 2 minus 20, so 55 minus 20 is 35. One more. This one doesn't go by the formulas that we have. You could just do it manually. Take 21 squared, 22 squared, 23 squared, 24 squared, 25 squared, 26 squared, 27 squared, 28 squared. See, it gets even saying it is messy. Or The trick I have here is I want them from 21 to 30. Well, that's the same thing as doing it from 1 to 30, but then getting rid of the ones from 1 to 20. So what is that? Well, this first one would be the formula with 30 in there. So 30 times 31 times 61 over 6. The next one's the same formula, but with 20s in there. And again, this is the sort of thing you don't generally just do 20 times 21 times 41, divide by 6 each time. I get 6,585. What does that mean? Well, that's an interesting question. It means that when we add that up 30 times, 21, 22, and so forth, we should get that number. Until next time, this is Dr. J.